Recording. All right. Okay, I think I'm recording just for Aubrey. Is that true? Yes? Yeah. Aubrey, this is page 81, homework assignment. I don't know. I just listed all the problems out here because they didn't kind of follow a pattern, and those are the ones that I like the best. So there you go. You might have to pause this to write those down. There is that. Did you get them all written down, everybody? Beautiful. All right, let's go through this. We have more angle pair relationships, all right? So I'm going to go up to the very top. Let's review. Let's talk about some things, all right? Over here off to the side in this little line of three. Let's talk about things. If I'm talking about two angles that are right next to each other, like this angle and this angle, what is that called? Adjacent. A-D-J-A-C-E-N-T means adjacent, right next to. How about if I have two angles like this one and this one that are making a straight line? They are a linear pair. Okay, we'll get to that. Are they also adjacent? Are these two angles adjacent to each other? Yeah, linear pairs are also adjacent, right? Okay. But not every adjacent pair is linear, true. It's like a square is a rectangle, but a rectangle is not a square. Yes, we'll get to that, okay? But then I heard Colton over here say supplementary. That's what we're going to learn today. Supplementary means that they add up to be?
180.
Yeah.
No, 180.
Okay. Linear pairs. Are linear pairs always supplementary?
No. Well, yeah.
Yes, if it's a straight line is 180, right? So a linear pair will always be supplementary, right? Okay. Do we have any more? Oh, what are these things called? This guy and this guy. Those are vertical angles. Okay. I'll abbreviate the angles part. Okay. Vertical angles. Those are the three main ones that we learned yesterday. Yeah? Anything else besides that? I think that might be it. Okay. What? Complementary, that's what we're going to do today. So we have complementary and we have supplementary. All right, here's the deal. Complementary means they add up to be 90. So circle the word sum of 90. Supplementary means they sum of 180. Do you know the difference between the two, or do you get them confused?
No, I got it.
Here's how you keep them straight. C comes before S alphabetically. 90 comes before 180 numerically. So C that comes first goes with 90 that comes first. Does that make sense? That is a stupid way, but that's how I remember it. Complementary is 90, supplementary is 180. Done. Got it? Now, here is the deal. These two angles right here are complementary. One is 30, one is 60. They add up to be 90. Yes, they are complementary. Those two angles are not touching each other. Do they have to be touching each other to be complementary? Do they have to be touching each other to be adjacent?
No. Yes.
Do they have to be touching each other to be a linear pair?
Yes.
Do they have to be touching each other to be vertical angles? Yes. They have to have the same vertex, right? Okay. But to be complementary, they don't necessarily have to be touching each other. If they are, great, that's fine. These two right here, 110 and 70, those are supplementary. They are not necessarily touching each other, right? Although they could be touching each other and be supplementary. That's fine also. So they don't have to be connected, but they can be, yeah? All right, down here, this is an example of where they are connected. These two angles are adjacent and complementary because 23 plus 67 is 90, yeah? These two are supplementary because they add up to be 180. They are adjacent because they share a side and a vertex, and they are a linear pair. So that's like all three of them in one, right? That's what we were talking about over here. They are a linear pair, they are adjacent, they are supplementary. Here they are only supplementary because they're not touching. Clear as mud?
Sure.
Okay.
I forgot what you said.
Let's go example 1. Go to the next page. Complementary and supplementary angles. This is where it gets a little hairy, folks. All right? Challenge yourselves. Find the measure of two complementary angles. All right, here we go. This is what you're going to do every single time. Find the measure of two complementary angles. Let's name our angles. Let's call one angle X and the other angle
N.
Y. I don't care what you call them. You can call them M and N. I don't care. What two complementary angles? One angle is X, the other angle is Y. Got it?
M and N.
Okay, here's the deal. X and Y are my two angles. If the measure of the larger angle is 5 more than 4 times the measure of the smaller one. 5 more than 4 times. What's 5 more than 4 times mean?
4x plus 5.
4x plus 5. That's what we'll say y is, right? Y is the bigger one. in this case, and x is the smaller one. So if we're saying y is 5 more than 4 times the measure of x, it's 4x plus 5. Got that? Okay, and we know that they are complementary. So here's my picture. Complementary means 90, right? They add up to be 90, okay? And I'm just going to make it look like that. Do you guys know what this little box in the corner means?
It's a right.
A right angle, so it's 90, right? Now, these two angles don't have to be touching each other, but they are in my picture, right? Okay? Which one is y and which one is x? The top one is y because he's bigger, and the bottom one is x because he's smaller. And y is 4x plus 5, yeah? Now, how do I solve any of these?
Oh, you what?
Set what equal to 90? Got it.
Y. 4x plus 5, and then you.
This guy plus this guy, right? 4x plus 5, that bigger angle plus, whoa, what just happened? Plus the smaller angle gives me 90, right? Big angle plus small angle is 90, yeah? All right, let's simplify. What can we do on the left side?
Add the x.
I'm going to say that that's 5x plus 5.
And subtract 5 over.
Okay, let's subtract the 5 over. 5x equals
19.
85. 85.
No, yeah.
That
It'll
is
be 17,
great
17,
math.
17.
Divide by 5. That
17.
is 17. You're right. X equals 17. Okay, so this angle right here is 17 degrees. Wow, I made him way bigger than 17 degrees, but that's fine. Okay, now, what's the other angle? What's angle Y going to be? He is going to be 73 degrees. How did you get 73 degrees? You can plug 17 into that equation, or I know that they both add up to be 90, right? Okay, so let me talk you through that again, because you'll have a problem like that on your homework assignment. One angle is x, the other angle is y. 5 more than 4 times the measure, that means 4x plus 5, right? That guy plus the other guy is equal to 90 because it's complementary. If they say supplementary, you're equaling it to 180, right? And then you just solve for x and go, right? Okay, not that hard. All right, lots of words though, but map it out. Write out what you're doing, okay? Let's go to perpendicular. Okay, go down to the very bottom. Let's talk about perpendicular lines. Tell me what perpendicular lines are.
They intersect.
They intersect. I like that. They intersect. But they don't just intersect.
They are 90 degrees.
Yeah, the intersecting would be like this. Boop. But those aren't perpendicular, right? Perpendicular would be they intersect at 90-degree angles. And then you put a box in the corner, right? Now, question. This seems silly, but I'll ask it, right? If this is 90 degrees in this corner, does this have to be 90 degrees in this corner?
No.
How do you know that?
Because the vertical angle also has to be 90 degrees, which
Okay.
means that the other angle also has to be
I
90
like that.
degrees.
Macy said, okay, if that's that, then the vertical angle, the one across from it, has to be 90 degrees as well, right? But then what is this guy in relationship to this guy?
Also 90
Degrees.
They're adjacent, but they are a linear pair, right? And don't a linear pair add up to be 180? So if this is 90, that has to also be 90, true? Right? And then this vertical angle has to be 90, right? So a lot of times when they do perpendicular lines, they will only put a box in one corner, but just know that there's a box in every corner. Got it? Like, that's just the way that it goes, okay? So perpendicular, they cross, but at a perfect 90-degree angle, okay? Now, sometimes they will do perpendicular lines that don't intersect completely. They'll meet like this, and they'll make like a T, right? So they don't have to go through each other, but they'll do like that, right? Okay, and they'll make a T, something like that, right? Okay, what is it called if the lines don't cross each other at all?
Parallel.
Parallel, okay. I don't think we have that on this section, but just so you know, parallel and perpendicular lines, there is that. Got it? Perpendicular. All right, now, oh, by the way, let's say we have, let me go back to my picture over here. Whoop. Real quick, look at this picture real quick. Sometimes they will do this. And they'll do this guy. And then they'll say, like, this is 20 degrees. And then they'll say, what is this one? 70. Like, that's not hard to figure out, right? Because that has to be 90 in that corner, right? So 70. Got it? Do we figure that out? Okay. Let's go to the next section. Go to example 2. We're moving right along here. Example 2. We're on this little, is this like a paper folding thing? Yeah. Tangram. Oh, it's not a paper folding thing. It's one of those like little, you fit the rectangle, the triangles together, right? Tangram. That's what, like Mrs. Crano has a bunch of those, right? Where you like
Yep.
fit them together and you make different shapes. This looks like a little dove thing, okay? Whatever. The tangram is a puzzle consisting of 8 flat shapes called tans, which are put together to form images. Find the values of x and y such that, here's the important part, AD and EC are perpendicular. Let's find where AD is. AD is this guy right here. And EC is here. And those two lines are perpendicular. Got it. So that means that this is 90, and this is 90, and this is 90, and this is 90. All right.
When they do B, it's just,
What shall we do first? What?
we can assume B is 90.
3y.
Well, okay. B, you're saying like this B. B is not this corner. B is that dot. So don't think about B as being like this area. B is that dot. That's just where they've labeled him. Got it? Okay. So 3y plus 15 has to be equal to 90. Yeah? Okay, let's solve for y. Let's subtract 15, which is how much? 75. And divide by 3. And y is 25. Do we have to plug back in, or are we solving for y and x? What does it say? Oh, find the values of x and y. That's all. Okay. All right, so we solve for y. How do I solve for x?
You put x plus 10.
Okay, real quick. Everybody look at this, because I want to talk about some things that we cannot assume. We're going to talk about what we can't assume here in just a minute. But here are some things that we cannot assume. Ready? This looks like he's like halfway between here, right? What's half of 90 degrees?
45.
Can I say that this equals 45 and this equals 45?
Nope.
The little line.
Not unless they tell me that they are exactly the same. That is something that we are not allowed to assume. Does that make sense?
Yep.
Are we allowed to assume that this guy is equal to this guy? No. Even though they look like they're equal, we don't necessarily know that this angle is equal to that one, because that would mean that they both were 45s, right? But what do I know?
Add them
Didn't you
together.
do 8?
You
15
add them together, right? Yep. Add them together, and they equal 90, right? If I add 7x plus 10 and 8x plus 5, what's 7x and 8x? 15x plus 15 equals 90. Do some math in your head. Let's subtract 15, which is the same as what we had before, right? 15x equals 75. And divide by 15, and that is that 5? X equals 5, and that is all. Okay? So, things that you cannot assume. Unless they tell you for certain those are equal to each other, you cannot assume that they're equal. Got it? Kind of like when you guys were doing the whole line thing and you had X here and you had Y here and they put Z in the middle. And I said, don't put him exactly in the middle because you don't want to assume that they're the same, right? Unless they tell you that they are. So put Z over here, right? You cannot assume unless they tell you, all right? Now, here are things that you are allowed to assume, okay? Let's go down here. Things that you are allowed to assume, okay? I'm on the middle of the next page. Here is what I can assume. I can assume that if this looks like a straight line, it is a straight line. So I can assume that this is 180 degrees and this is 180 degrees. Does that make sense? I cannot assume that since this angle looks about the same as that they are the same unless there's the little loop-de-doos in there. That is something I cannot assume. Does that make sense? Straight lines I can assume are straight lines. Got it? Other things that I can assume. Lines that appear perpendicular may not be perpendicular. Angles that appear congruent may not be congruent. Segments that appear congruent may not be congruent. So, if they have a little T like this,
You can't say
I don't know if I agree with that. Oh yeah, I do. I do agree with that. So if we have this going on here, I can assume that this is a straight line, meaning this is 180 degrees, right? And I can assume this is a straight line, meaning this is 180 degrees. But I cannot assume that that's a perfect 90 unless they tell me that they are perpendicular, right? Because they could be ever so slightly not 90 degrees, right? Does that look ever so slightly not 90 degrees?
Yeah.
Okay? And I cannot assume that those are 90 degrees or perpendicular unless they tell me that. I can assume this is a straight line and I can assume that is a straight line. But I cannot assume that that's a 90-degree angle unless they tell me that, okay? Those are things that can be assumed, cannot be assumed. Questions about that? Okay? They call that committing a suicide. Okay, whatever. Okay, you're fine. You're fine. You're fine. All right, example 3.
How long have you been
Ha ha ha. What?
How long have you been holding that in today?
Not that long, actually. Okay, moving on. Example 3. Woo! All right, determine. I need a Dr. Pepper. Woo!
You need a
I haven't had a Dr. Pepper yet today. I'm just like ready for one. Here we go. You're in season. You can't have one. No, I'll get one later. I'll get one here in a minute. What?
poke it with my pencil.
You've had 2 today? Are you in football?
I'm here playing.
So? Why?
Okay.
What's wrong with you?
Next week for you guys' first game.
Oh, how long do you have to be out? Are you kidding me? Does it like hit your system that hard? I've never had mono, but I had a friend who had mono like once, and it really, yeah, it like just tuckers you out, doesn't it? Yeah, I bet. Yeah, that sucks. Okay, is example 3 our last one? Yep. Okay, last one. Example 3. Let's. Oh gosh. Oh my gosh. We're gonna skip some of this. Here we go. Here's your diagram. Here's your diagram. Can we assume each of these? Shh, listen. Can we assume each of these? Can we assume that? You gotta listen. Shh. Can we assume that CE, which is this guy, and CF are opposite rays? Yes. Because that is a straight line, we can assume that they're opposite. All right, can we assume, let me get rid of my stuff here. Can we assume that BGC, that angle right here, and KGC, this angle right here, can we assume that they form a linear pair?
Yeah.
Yes, because we can assume that's a straight line, so that is a yes. Okay, next. Can we assume that ABJ, this angle right here, and CBG, can we assume that those are vertical angles? We can? Can we?
Yes.
Yes, because they make 2 straight lines, so we can assume that they are vertical angles, yes. Okay? Yes, they are formed by whatever. All right, so they answer the question for us. BCG, this angle here, and DCF, this guy right here, can I assume that those 2 are congruent?
No.
Unless they do the little loops like I just did, we cannot assume that, so no.
What do you mean?
They said, can we assume that this angle and this angle are the same?
But
What? No, these angles are not vertical angles. There's not enough information given. They were on part D. Right? BCG and DCF? Yeah? No? Yeah? No, these angles are not vertical angles. All right, BE and IF are perpendicular. BE, whoop, this guy right here, and IF are perpendicular. Do we know that for sure?
yes. Yes. It's a T.
But they don't have it marked. It could be slightly this way, right? We don't know for sure. We cannot assume that those are 90 degrees unless they put the little box there. So no, we cannot assume that. There's not enough information given. EBC, stay with us. Shh. Stay with us. I'm on F. EBC, this angle right here, and GBC are complementary angles. Do I know for certain that these 2 angles add up to be 90 degrees? No, because there's no box in this corner. I don't know that that's a 90 degree angle, so no. Okay, on G, we have 2 left. ICH. This angle right here. And HCD. Are they adjacent? Meaning, do they share a vertex and a side? Yes, they do. Okay. All right, last one. B something. BC is an angle bisector. BC is an angle bisector of ECG. So this guy splits this angle in half. Do I know that for sure?
No.
Like they would have to have loopy things right here and right there, right? In order for me to know that. Okay? So, do you see what we can assume and what we cannot assume?
Yes.
Perfect. All right, do your homework. There you go. Homework is there.
Can I go talk to